Good morning, friends. Let's continue our discussion about the stacks. So, in the previous two videos, we have seen that how to implement stack using our own implementation without using any Java collection. And the first follow-up one was to use the Java collection, that is Java util.stack. Now, in this video, we will see the follow-up two, where we have to implement a bounded concurrent stack in Java using logs. So, by bounded means that we will be having a capacity predefined capacity, which means that if the capacity is hit, no more elements can be pushed into the stack, and the thread has to wait. And similarly, if the stack is empty, in that case, we have to wait for the consumer threads to pull out any element. So let's implement this. So I've got my IntelliJ open, and I've created a new class, something as my stack using logs. So let me make it generic and implement StackI, right? Okay. So we have got this class where we will implement this, and alt enter implement methods. So we have got these three methods to implement. So as mentioned that we will be having a final capacity, which is should be int, because this is a bounded stack, right? So we will be having a capacity here. I just mark it as int. And also I will use the stack, which is available in our Java API. So in Java, so java.util.stack. And I will use it as an underlying implementation for pop, push, and peek. Okay, so this is to done, and let's create some logs, because we have to make sure that the producing threads and the consuming threads both are properly synchronized over this common stack that is being manipulated here. So for that, I will use a log object, log, and I will create two conditions. One condition should be the stack not empty condition and stack not full condition. So not empty condition would be happening when the stack is empty. And similarly, let's line the code and then it will be more evident. So let's condition stack not empty condition when the stack is actually not empty. And similarly, stack not full condition. Because I have marked all of these as final ends, so I have to get a constructor now. So alt insert constructor, and it will take all of these values. I don't need all this as pass as parameters. I will just pass a capacity parameter. I will remove all this. So we are only providing this capacity, and inside this, now we have to initialize all this. So here I will just put new stack, and in the log, I will create new re-entrant log. Okay. And then from this log only, we will create two conditions. So for this, we can use log.new condition. Similarly, here also log.new condition. Okay, so we have defined capacity, which is the parameter which would be used when we create this object using the constructor argument. And after that, in the same constructor, we will initialize all our stack, logs, and the two conditions that we have defined. Now let's implement pop first. So for this, I will create a try catch, because we are going to use log. So we have to release the log in the finally. So what I do is that log.log. Okay. And in the finally, I will release this log. This is the log pattern that we have to always follow, that whatever conditions happen, we have to finally block, we have to release it. Now inside this, let's write our actual implementation. So as mentioned that if the size would be 0, it means that pop cannot take out anything from the stack. It cannot retrieve any value. So we have to check that condition, that whatever threads are trying to pop, we have to check whether the size is 0 or not. So I will check while size stack.size, because we are using the stack implementation of Java, It already has this size method here. So if 0, so it means that stack is empty now, right? This condition states that stack is empty. So this condition, right, that stack not empty condition doesn't hold true now. So we have to call an await signal here because our stack is actually empty now. So this will be calling await. Okay. And because this is throwing an await throws interrupted exception. So I will create a catch block here. Catch. Use final interrupted exception E, and simply I will print the stack trace of this. So all of these like sleep, join, notify, and all these like blocking methods in Java, they always throw interrupted exception if the thread is interrupted. And this is another way that how to stop a thread. So again, let's revise this. So we have got a lock here first, and then we release it finally. And inside this, we have this checking this that if the stack size is 0, there's nothing to be popped out. So our this condition that this stack is not empty, it doesn't hold true anymore because the stack is actually empty. So all the threads should be waiting on it to have some value first before it can proceed further. So after this, if another thread which is pushing the elements has like succeeded, and our empty condition would be being signaled that that a new element is available, only then the pop should be proceeding further. So it would be this step. After this, it will be already notified, and then from here we can return stack.pop. So if the thread has come out of this loop, it means that there has been already an element which has been pushed into the stack. That's why at this point we are sure that the stock has got at least one element, and we are popping that element. And finally, once we pop the element in the finally block, we have ensured that because the elements has already been there, so it would never be any in the full condition. So it means that we have to signal all the threads that the stack is not full anymore. It has already been popped and the capacity would have been reduced by 1. So it would be more evident once I actually write the push method as well. Then it will be very clear that how these conditions work all together, because we have to synchronize everything between pop and push on these two conditions. So let's implement this push method now.